Hello and welcome back. Now we are going to perform static analysis on CrackMe 4. So if you have already deleted your CrackMe 4, you can head over to this website and re-download it. So this is what it looks like when CrackMe 4 is run. It will display the time days remaining for the trial period of the software, and you're supposed to crack it to extend it beyond 30 days. So let's get started. So now let's open CrackMe 4 in the x64dbg. And the first thing we do is make sure your options are like this. System breakpoint and TLS callbacks are unchecked, and exceptions are 8 zeros and 8 Fs. Now we will analyze it with Xanalyzer, so you need to install the Xanalyzer plugin and only check these two options. So we right click anywhere in here and then head over down to Xanalyzer and select Analyze Module. Now you see the thick black lines here. Now when you run the program, let's run it. You will see the status 20 days trial period remaining. So let us copy the text and put it in our notepad. So this is an important text, so we look for this text. Maybe we just say trial. Copy the word trial and then search for the text in the code section by right clicking anywhere here and then selecting search for current module string references, and then you can see, okay, there is one here, trial period expired, another one here, trial period remaining. So you can select any one of this and then go to it, right click, follow in disassembler. Now you can see we are in the correct function. This function begins from here as indicated by the thick black line and all the way extends down all the way to here. So we're going to analyze this function. If you do not see this thick black line, just repeat the analysis command which we did previously, that is to right click, go down to Xanalyzer and just click Analyze Module. So now we are going to use our graphical tool on this function. So select the first line of this function and then press G on the keyboard. And now you will see it has performed the graphical representation for our block of code. And you can see from here it starts from this main block in this function. And then down here there is a decision whether to show the bad message, trial period has expired, or to show the good message, how many days remaining. So in our case, it is showing this message, 20 days remaining, 20 days. So, and the decision is done over here, JG decision. So JG means if jump if greater. So if you are comparing ECX, whether it's 0. If the ECX is non-zero, then it will jump to this instruction. That means anything above 0 means true, so it will go to the green. On the other hand, if ECX is 0, then this will be false. Then it will go to the red one and show you the bad message. So we want our ECX to be bigger than 0. So if you analyze further high up here, you will see that it is performing some kind of arithmetic. You see? So what controls the value of ECX? It is this line. So if you minus EX from ECX and store the result in ECX, and if the result is 0, this condition will be false and it will jump here. So if you, after minusing EX from ECX, you get a number which is bigger than 0, then ECX here will not be 0. So if it's not going to be 0, then this will be true. It will go over here, jump greater than 0. So we want ECX to be bigger than 0. So in order for ECX to be bigger than 0, we have to make sure ECX has a large number. So if you look up here, this is where we assign the value 1e to ECX. Now what is 1e? 1e is in hexadecimal. So we are going to convert 1e to decimal to see what it is in decimal number. So 1e, let's convert this now. We copy this 1e from here and then go to any online hex to decimal converter. And you can click this one, for example. And we can now key in our 1e and convert it to decimal, and we see it's 30. Okay, so 1e is 30. Alright, so now let's go back to our analysis and try to understand the logic behind it. So in this line, move ECX 1e means that you are assigning ECX to be 1e, to be 30. And over here, you are minusing EX from ECX. In that line, you are taking ECX minus EX, and then you assign the value back to ECX. So this will work out to be ECX 30 minus EX. Okay, so if you take 30 minus EX, your value here will be the result of this arithmetic, and we know that ECX here will be bigger than 0. Yes, it will be bigger than 0. So if you want this number to be as big as possible, this value should be as big as possible. So what we need to do is to crack this line, patch this line to put a big number, for example FF. So if we were to assign FF, that means if we assign FF to ECX, sorry, it should be ECX, and FF in decimal means 256, 256. You can go here and check it out. FF is 255, sorry, it's 255. So that would be a really huge number, yes? So if you minus 255 over EX, you get a big number. So let's go there and do that now. So we are going to patch this line to become a huge number. So we right click, follow in this assembler, and we get this line. So now all I have to do is assemble it by double clicking, and here we put a big number. Instead of 1e, you put FF, and make sure check to see whether the instruction is okay, same size, okay, click OK. So now you have patched this, yes, and we can test it. Click on run. Okay, so we have to restart, but before we restart, we have to patch it. File, patch file, and there'll be 1 byte patch. Click on patch file, and then we can save it as another name, maybe PACH extension. Click save. Patch. Okay. Now we can go and directly open the file, and you see we have 245 days period remaining. So what just happened? What just happened is over here, when we put a big number 255, it will minus EX from 255. So over here, what happens is, because EX is now 255, so I'm going to change it to 255. So you are taking 255 and minus EX, and the result we get is 254. 254. 245. So we are getting ECX will become 245. Yes. And today's date as I'm creating this video is 10 of July. So that implies that EX is 10, referring to today's date. Yes. So if 255 minus 10, you get 245. The original value was 30, and today is the 10, so 30 minus 10 gives you 20. Okay, so this is how you can use your graphical tool to perform static analysis and understand the code better and help you to crack the software. So the important thing to note is, whenever you want to crack the software, you will first use the debugger in a normal way by searching for the bad message string either in the code section, or another way is to use the call stack method to pause the debugger and head over to the call stack and go to the code which shows the bad message, and then perform xAnalyzer analysis to show up the block codes, and we need to have the block codes like this. Once we have all the block codes marked out in black like this, then we are ready to use the graphical tool. So that is how we perform static analysis. Thank you for watching. I'll see you in the next one.